I am still in the graphic organizer section. We just looked at this resource from Mrs. Brosseau's binder. And on this next page, you just need a sheet of notebook paper. So just a blank sheet of paper. Let's give it the title, Section 1.2. That's Chapter 1, Lesson 2. So we have 1.2. This is called the measurement matrix. Okay. And then you just need to draw a large box here on, I would recommend using a straight edge. This is the beginning of the matrix that we're going to draw. So just draw yourself the box. I didn't do a very good job of getting on the lines. You can pause the video if you need to. And then once you get this big box drawn, we are going to have 4 columns. So you can eyeball it. You don't have to measure. Whoa, let me straighten that up. So here's column 1. That is still not straight. That's pretty close. And then we need to copy that same practice over and over. I need 4 columns. So here's column 2. They don't have to be exactly equal. If you want to measure, if I weren't doing this with you, I would measure it because it drives me crazy. But I can live with that for right now. So here is a matrix with 4 columns. And then we are going to need 1, 2, 3, 4, 5, 6, 7, 8, 9 rows. So I think just to keep mine straight, I'm going to come down here and put in maybe 4 rows. Some of them don't need to be quite as much though. So let me think just a second. Let's go ahead and do it this way. Let's put in a row, just 1 line is fine, for the headings. And our headings we'll add in just a minute. The first one, let's put 4 lines. And then maybe 5 lines for the next one. And then for the next one, maybe 3 lines. I think will be plenty. And then the next one, I want to do 1, 2, 3, 4, 5, 6, 7 lines. That's a big section. It's going to be for time. Temperature, we'll do 3 lines. And then 3 lines. And 3 lines. It worked out just perfectly, didn't it? If yours have more than 1 or more lines, it's okay, as long as you have something similar to this. If you need to, pause the video and get your matrix drawn. A matrix, another way to describe a matrix is a comparison table. So if you need to compare things, this is one very good tool, especially if you're comparing a lot of things. If you're just doing 1 or 2, or if you're just doing 2, I would use a Venn diagram. But if you're using more than 2 things in your comparison, this is the way to go, in my opinion. Okay, the headers. Let's label the columns here. So the first thing that we're going to label is the quantity. What are we measuring with each of these? And then we're going to tell how it's done in the standard system that we use in America, the metric system, and then we're going to add in the SI. And remember, SI is an upgrade of the metric system that we talked about in this graphic, the International System of Units. There are 7 of those units. Okay, so if the quantity we're measuring is distance, the amount of space between 2 points, in the standard system, you will use the fact that there are 12 inches in 1 foot, there are 3 feet in 1 yard. There are 1,760 yards, and I'm going to have to abbreviate that one, in 1 mile. And there are 5,280 feet in 1 mile. So if you're in the standard system and you want to measure distance between points, these are the units that you need. The standard system requires you to memorize a lot of conversions. If you are talking about the metric system, you're measuring distance, it is going to be based on the meter. And then you use your prefixes. So a kilometer is 1,000 meters or kilometer. A hectometer, I had to stop and think, is 100 meters. A decameter is 10 meters. So the meter is your base unit. That's going to be right in there. And then we go to those really tiny measurements, like a decimeter. That's 1/10 of a meter. So you take a meter and you divide it into tenths. Then centi is 1/100th, and milli is 1,000th. Okay, so the basic unit for a metric distance is the meter, and you add your prefix accordingly. Okay, the SI, the standard measurement unit, the International System of Units, says that we use the meter as our base unit. Because remember, SI is scientific, so it's going to align to the metric system. So that's if you want to measure distance. What if I want to measure capacity, amount that something holds? So capacity if you're talking about the metric system, I'm going to do this one first, is a liter. Many of us buy 2-liter sodas when we have guests over or something. That is a bottle that holds 2 liters. We buy water in liters very often, just a bottled water. Okay, I'm just going to copy and paste this because it's the same. There's no need for me to well, I guess there is. I thought I could cheat there. If you put 1,000 liters in a barrel, you have a kiloliter. If you put 100 liters in a barrel, you have a hectoliter. If you put 10 liters in a barrel, you have a decaliter. If you take your bottle of water and you share it with 10 people, each will get a deciliter. If you share it with 100 people, each will get a centiliter. And if you share it with 1,000 people, each person would get a drop or a milliliter. That is a very tiny amount. So liter is the base unit in the metric system for capacity. Now, there is not the use of a liter over in this, in the SIs. There's not a designated one. So I'm just going to leave that column blank for this one. There is a quantity that we'll talk about a little bit further down. All right, for capacity in the standard system, this gets a little bit complicated. So I'm going to, first of all, I'm going to shrink my pen size so I can get all this in. There are 8 fluid ounces in 1 cup. There are 2 cups in 1 pint. There are 2 pints in 1 quart, which means there are 4 cups in 1 quart. There are 4 quarts in 1 gallon. There are 8 pints in 1 gallon. And there are 16 cups in 1 gallon. And I could keep going, but I won't. These are the basic conversions in the standard system. So I had to learn all those. I had to memorize all those conversions. In the metric system, you don't memorize. You just swap out these prefixes. And I think I'm going to go ahead and add, with kilo, you are multiplying by 1,000. Hecto, you multiply by 100. Deca, you multiply by 10. Deci is dividing by 10. Centi is dividing by 100. And milli is dividing by 1,000. Okay. Okay. Let's move on to the next category. And this one is going to be mass. Remember, mass is the amount of substance in something. The amount of substance. Think of Neil Armstrong. Excuse me. If you're talking standard units, we have 16 ounces. Let me spell that out for you. Ounces in 1 pound. So a half pound would be 8 ounces. You can do halves or quarters. And then we have 2,000 pounds in 1 ton. So a small, very small car, a tractor, a horse, a large horse, 2,000 pounds in 1 ton. So those are the units if we're in the standard system. If we're in the metric system, you guessed it, the prefixes are the same, and I'm going to squeeze those in here. We have kilo, which is times 1,000. We have hecto, which is times 100. We have deca, which is times 10. And then we have deci, which is divide 10. Centi, divide 100. And milli is divide 1,000. The basic unit for for mass in the metric system is the gram. So you can have, for example, an elephant, a small elephant would weigh 1 kilogram. A box with books in it could weigh a hectogram. A decagram could be a large bird. A decigram, could be a small paper clip. Centigram could be a large aspirin. A milligram would be part of a small aspirin. It's a very, very tiny amount. In SI, the chosen unit is going to be the kilogram. And remember, SI are the standard units, and that is over here from this chart. A kilogram is the standard unit of mass. Okay, time. I know that in SI, the basic unit is a second. Let me just go ahead and spell these out for you. And then we had a meter already. Okay, and the symbol for meter is M. I'm not doing a very good job with this matrix, but we're getting there. If you are talking about the standard system, we have, one day, actually, if you've already written it, don't erase it. I'm going to start with seconds. And I think I better shrink this a little bit. So we've got 60 seconds equals 1 minute. 60 minutes equal 1 hour. 24 hours equals 1 day. That's the time it takes for Earth to go through night and day, spin one time on its axis. 7 days equals 1 week. Now, there are usually 4 to 5 weeks in a month. The months are different, so I won't add that one. There are 52 weeks in 1 year. There are 12 months in 1 year. And there are 365 1/4 days. This is the time it takes Earth to travel one time around the sun. And that 1/4, every 4 years, we have a leap year. That makes up that 1/4 day. That's why every 4 years, a year has 366 days. And that will happen in the years that we elect a president. Leap years coincide with presidential elections. So if you're trying to figure out, is this a leap year? This one is not, because we are not voting for a president this year. Good news is that this is the same in the metric system. You don't have to remember new units for the metric system. Now, if you learn these, actually, never mind that. Just disregard. I was about to go down a rabbit hole that I don't want to go down. So I'm going to go ahead and crop this. I will put it in the metric system. You don't have to write it again if you don't want to. It's up to you. Just know that those are the same in the metric system as well. But in the international system, they have chosen the second as the basis. Because if you know a second, you can build all these others. Okay, we're getting there. The next one is going to be temperature. Temperature is always measured in degrees, but it's going to be a different thermometer depending on the category you're in. So if you're in standard, we use the Fahrenheit thermometer. So we would say Fahrenheit degrees. The symbol for degree is that little circle up there. Just a couple of things here. Water boils in this system, the standard. The boiling point of water is 212 degrees Fahrenheit. And water freezes in this system at 32 degrees Fahrenheit. In the metric system, you have the Celsius thermometer, and sometimes you see centigrade for this scale. There's that prefix, centi. In the metric system, water is going to boil at 100 degrees. There's the 100 that goes with centigrade. So 100 degrees Celsius or 100 degrees centigrade. Water freezes at 0 in the Celsius system. So 0 degrees Celsius is the same as 32 degrees Fahrenheit. In the international system, we use degrees Kelvin. And I am so sorry, I do not know what these temperatures are in Kelvin. Let's just Google that and see what we get. So I'm going to bring up a Google. Kelvin boiling point water. I should know this, but I don't. It's been a long time. So water's going to boil, and I'm Googling that, at 373.1 degrees Kelvin. I did not know that. So water boils. I'll tell you what, let me redo this just a hair. At 371.1 degrees Kelvin. And then let's do the same Google search and figure out when water freezes. Google is an awesome tool. If you don't know something, stop and look. Don't assume that you'll know it the next time. 273.1. So these would not be, well, they are different. So they're kind of the same to remember. But okay, so those are the Kelvin points for water's boiling. Okay, electrical currents. You'll like this one. In the standard system, it's the ampere. And remember, the symbol for that is capital A. That's important. Lowercase a means something else. So ampere. It is going to be exactly the same in the metric system and in the Kelvin, or in the, the SI system. So ampere is the same across the board. I like that. Substance, and this is referring to chemistry. The atomic substance, chemistry. In the standard system, it's measured by the mole. Symbol is MOL. Good news here. It is the same across the board. It's where that phrase across the board comes from. It is literally across the matrix. So we have it all the way across. Same with light, luminosity. And I like that word, luminosity, but let's go ahead and put light in there too. And then this is the amount of light that is being given off Now, I need to check this before I tell you. I can tell you in the SI, it's the candela. Think of a candle, how much light is giving off. And I think that's actually what it refers to. We'll check that out. It's the, for example, if you have 1,000 candelas, that's the light of 1,000 candles, I believe. But let's check that out first. Let's just Google the meaning of candela. And I could just be making that up completely. It may turn out to not be, but I believe I've heard that at some place in my life. This is good for me to review. Candela meaning. It is the standard unit of luminosity intensity. One candela is the intensity in a given direction of a source that emits radiation at a certain frequency. So it doesn't say anything about candles. Let me just Google that to see if there's a connection there. No, there's a company called Candela. But okay, so I want to check for luminosity unit, standard system of measurement. Now all I did, guys, is go to google.com and start typing, and then I get all these great things. Okay. Okay, I thought we were going to get into this issue. I'm not going to dig into it. Let's just call it a candela across the board, okay? So that same unit can be used, and I will be honest with you, I personally have never done a math problem about candelas, but it could pop up, and you could see that word in a science book. All right, so here is our completed matrix that shows us the units and the conversions and all the good stuff in each of these areas. So, hopefully that has helped you to understand the 3 different systems. It also shows you that in the standard system there are lots of formulas to memorize. In the metric system, there are 6 prefixes that we have to memorize, and then our base units. So I hope that between these 2 pieces, you have learned some more about measurement. We will be using measurement throughout science, so I'm sure we'll see these again. I can't remember what our next video is about, but it'll be something good. So I will see you soon. I hope you have a wonderful day. Bye-bye.